Yes. Now, because we already studied the types of classification, this is a little extension of concept for better understanding because we may get many questions based on the concept. Now, if you see here, first let us discuss natural classification. What is the basis of natural classification? Sum total. We are not taking one, two, or few. We are taking many. Sum total of characters of its members. So I have n number of characters, not little, n number of characters common in all the organisms in the taxon I classified based on the natural classification. We always use the word natural affinity when it comes to natural classification. What do we mean by the word natural affinity? Natural affinity means, affinity is what? Inclined for same characters. This meaning works me if I have to make you understand natural classification better. So now let me take you through an example. My father has three brothers, two sisters, and we, the children of all the six siblings, are cousins, and we tend to have more similarities among us when compared to our similarities with distant cousins. So naturally all of us will share the same surname, and we tend to have more characters alike in us because we belong to the same bloodline. This is important. Think in the next generation, our children will also have affinity towards each other because they are again from a common origin, naturally inclined for same characters. So we see this natural affinity if it is from common origin. I don't exactly mean evolution here. I am speaking about origin. So my father's dad, then my father's siblings, then we, then our kids. Aren't we from the same common origin? Naturally, the similarities amongst us will be more than the other group of the same family. This is from common origin and sharing natural affinities. So when we consider common origin, the descendants will have most of the characters in common. So if I create one taxon based on common origin, I can actually group many organisms with many similarities in that group. That is where natural system of classification takes upper hand on artificial system. Then the advantages, hereditary constitutions. Hereditary constitutions means common origin. So for instance, you take gymnosperms. All the gymnosperms are from a common origin. So everything which I have called as a gymnosperms will have naked seed. Everything which I call as a gymnosperm will have a cone. Yes, and everything which I call a gymnosperm will have the types of leaves described, the types of stem described, and the types of root described, taproot system, softwood. So because they are from the common origin, so I can bring a huge group of plants under the name of gymnosperms because I am considering hereditary characters based on common origin. General groups together plants most closely related phylogenetically. Phylogenetically means evolution. You already know this. When they are from a common origin, they share the same evolution. So the changes are similar and similarities are also great. Great deal of information about its members. We tend to cover many things when it comes to common origin descendants, because they have natural affinities. Easily incorporate additional information about its members. Suddenly I was understanding evolution. I found there is something else which has to be added. Then naturally I can add it to the group because I am basing on common origin. I don't see too much deviation. High predictive value, yes, because I am following how they evolved in the nature from a common origin. If I have 100 people going in one road, and if the 101 person is like 100 people from the same family of 100 people, he is unlikely to go in another road. So my prediction is almost close to 100% because he would also go in the same road because he is following the path. Predictive value is very high. Disadvantages. Identification may be difficult because looking at the plant I can't say to which taxon it belongs to because I should know the evolutionary history. If any plant is with little evolutionary history or with little natural affinities, for me it is impossible to classify under natural system. And if suddenly I understand that there was a divergence in evolution, then I may have to change the position, and if I increase my knowledge about the evolution, if I see there are many diversions in evolution, maybe the criteria of classification is liable to change. Based on natural affinities, covers many characters in common because we consider common origin. We also consider evolution in common because the ancestor is common. So when I tend to classify based upon evolution, I am likely to place it wrong. And if I have an increase in evolution, then the criteria may be liable to change. Then I have again organism placed properly based on its phylogeny. So these are the points under natural classification. In another concept video, I shall do artificial.